Now we found all the differences in our table for our heights, but I want you to take notice of how the time changes. Because I for sure can see by this, it's not appearing as a constant change right out of the gate. I do see the same change though in these parts. Down 1.4, down 1.4. What do you notice, Rashad? Rashad's picking this up. These two places right here where the change was down 1.4, it was when we went up 5 minutes. So our 1.4 change happened at 5 minutes. And look over here, this change was double. What's the change in time right there? So that's a change of 10 minutes. And over here, I'm wondering if 1.4, this is interesting. This one's got 2. You know what? I'm not even worried about messing around with this. I'm pretty comfortable right here. This is changing down. It's going, describe the relationship between time and minutes and the shuttle's height above the Earth's surface. Every 5 minutes, the height goes down 1.4 kilometers. I'm dealing with that negative by using the word down in front of it. Every 5 minutes, the height goes down 1.4 kilometers. Now, what we know from our work with linear functions is that a linear function we can set up in a y equals mx plus b. B is always when x is 0. What's our b value in this case? At 0 time, how high was the shuttle? Look in your table. When x is 0, our height was, we started at 100. My b value is going to be plus 100. But let's talk about how this changes. We've got a difference of, and I got to use this and put it into a unit rate. We've got a difference of, it's going down 1.4, but that's happening every 5 minutes. So you need to get this down into a unit rate. What is going to be every 1 minute? Take negative 1.4 and divide it by 5, and there's your constant rate, or your slope for your equation. Say it if you've got it.
Negative 0.28.
You guys agree? Negative 0.28? Yeah. So down 0.28 every minute, starting with 100. Time was x, height was y. Now in number 22, it's asking us how far above the Earth was the shuttle 2 minutes before. Let's find out what was going on 2 minutes prior to it hitting 0 and 100. Plug in x equals negative 2 into your equation. Negative 0.28 times negative 2 plus 100. Before this started, it was already descending. Where was it 2 seconds prior to? What do you got, Brandon?
It says 105.6.
I agree. 105.6 kilometers. And I let the 2 minutes before be represented as x is negative 2.